Tonight is January the 15th of 2016, and I want to show you what I have been playing with, and primarily what this is all about is this little transformer right here. I bought two of them. They're rated at 20 watts. They have an 8K primary, 4/816 ohm output, and this little amplifier, which used to be the 6B4 amp, I'm using to evaluate this transformer, and it's turning out very nice. I'll show you the specs. Let me show you the second one here. One of the things I like about it, this is the second one. See, this right here comes off. It uses these 4 screws right here to hold it to the chassis, but you take this off and you can use this to, lay on your chassis and mark the holes, etc. And then you put this back on from the bottom. I'll show you underneath here if I can here in a minute, and it makes a nice installation, so I like that. What I did, well, let me show you what I've got right here. What I've got is this amplifier right here. Turn that darn light off again. What I've got is this amplifier right here, and it's exactly like that except for the 2 output tubes and the transformer. Now, you could build a lot of the amplifiers that you see in schematics. This is an Acrosound, uses a TO250 transformer. I think these are all really nice designs, but the problem you're going to have in just about every amplifier is finding the exact output transformer that they use. So you've got to do what you got to do and get what you can get. Well, when you do change this right here, you're going to have to figure this out. You're going to have to figure out your feedback, because the components that they use with a different transformer is not going to give you a different transformer with this and these same values is not going to give you the right amount of feedback. So you got to figure that out. Okay. There's a really nice book out, which I have. Let me show you here. Called Audio Encyclopedia. That's got some really good information in there, and I've been studying it. But sometimes it's just easier to do it by experimentation, and that's why I'm doing this one. Now, what I'm measuring right now is its output. You saw the video I did recently. This is its output in dBm, 43.0, 43.01, 43.01. Write that down. Now I'm going to put the amount of feedback that I have determined is exactly the right amount in it, and I'll show you how much it is. I've got to hook it up and be right back. Okay, I've hooked the wire back up to this pot. What I did is installed a, I believe this is a 100K pot, so I can vary the feedback resistor to whatever I want it to be. I have not installed a capacitor across it yet, but here it is afterwards, 27.366. Well, you write that down, that's a 15.6 dB of feedback, which is, I didn't do this on purpose. I very painstakingly tweaked it in. Now, the one I measured the other night was about 19 dB, and I understand that even 20 dB is pretty reasonable for a tube amp. But let me show you something. Okay, first of all, we'll start out. Here's our plate current. I've got it set to, let's see, one tube is 43 milliamps. The other tube is 40 milliamps. So we got a nice set of fairly nicely matched tubes. I can vary the bias right here. So I'm running them pretty hot, running them pretty close to their maximum plate dissipation. I don't have to put that back on. And what we get out of it at 20 watts, well, we'll just start. Okay, well, I've already got it set to about 1 kilohertz. Let's look at this guy. Touch it up. There's our 1000 hertz. At 20 watts. Let's see, this is measuring watts right now. Let's start cranking it up. One, if we go by 10 dB, that should go up to 10 watts. There's 11. $19.22. There it is. There's THD. 3.77, 3.8%, or 0.38%. It's pretty good. That's at 1 kilohertz. Here it is at, let's see, no, I'm sorry, that's 2 kil. No, that's 1 kilohertz. Yep, I'm sorry. Okay, here it is at let's go up to 2 kilohertz so I can go down to 20 easily. There it is, 0.372 at 2 kilohertz. At 100 hertz, this is what it goes to. Goes to 0.47. There's our 200 hertz. I'm sorry, I put it in 2 because I can go to 20 hertz and I can go to 20 kilohertz without a lot of knob turning. And there's its nice sine wave. And then finally we'll go to 20 hertz. Here's 20 hertz. Looks pretty good. Actually, there it is, 20, 21. And our distortion is right at 1%. 0.8, 0.9 to 1. Pretty good, huh? Its power is 15 watts. Okay, here's how much it drops in decibels. There it is at 20 hertz. It's 41.8 dBm. There it is at 100 hertz, 42.82. Here it is at 2 kilohertz, 42.8, same number. And at 20 kilohertz, it actually goes up ever so slightly. And I actually see that on the plot too. I see the same numbers when I run the HP 8903 and plot it, and I'll show you that plot too. See, there's its power at 20 kilohertz. There's its power at 2 kilohertz, 200 hertz, and 20 hertz. It'll get there in a minute. It takes it a second to settle down. Yeah, I believe that's right. And we can verify that right here. This thing does, there it is in decibels, there it is in actual power. And there's its voltage. So there's its power. So it drops slightly. Well, we've already measured it in decibels and everything else, so everything's recorded. That's at 20 watts or thereabouts. 20 watts at the mid frequencies. And the transformer is rated at 20 watts, 19.19. Let's push it a little harder. There it is. There's up at 24. And see, its THD is still 0.44. Let me see if you can watch both of them. Okay, here's its power, and here's its distortion. And we'll keep rising until the distortion gets to at least 1%. There's 32 watts. So this, remember, this is a 20 watt transformer, what they rated at. So at 32 watts, it's still only a 0.5% THD. At 43 watts, it's 0.664. That's not bad, huh? Okay, well, we're gonna go over the edge here in a minute. At 48 watts, well, it's actually starting to clip there. It went up to 3%. So you can see it clipping. We got a little bit of notch distortion in there. But if I back this thing down, even one, even 1 decibel, we can get 43 watts out of it at 0.6% THD there at 2 kilohertz. Let's see what it looks like at 200 hertz, still only 0.8. Let's see, 20 hertz. It's probably going to get a little weird here. 43 watts is just not fair. Let's back it down some more. 30 watts. 30 watts. Okay, let's do this again. Okay, there's 200 hertz. 32 watts, 0.69. 20 or 2 kilohertz. Can't say anything right tonight. Half percent THC, 20 kilohertz. THC went up quite a bit there, didn't it? And 20 hertz. Whoops. Oh darn, I'm pressing the wrong one there. 20 hertz. Power went up slightly to 25 watts. There it goes. At 3%. But it actually doesn't look too bad. There's 20 hertz on it. So it's a very extreme. It's 20 hertz, and of course the mid frequencies just look marvelous if they're even at 30 watts. Yeah, there's 20 hertz, 20 kilohertz. Yeah, it's getting a little triangular there. But you know, that's way beyond what the transformer is rated at. Backing it down just ever so slightly, even to 25 watts. Well, there it is, 25 watts, it's at 4%. And back down to 20 watts, it's at 2% at 20 hertz. That's with the amount of feedback I have in it now. Okay, let's go into a slightly different subject. The transformer seems to be performing pretty well. I can't complain about it. Let me show you something that I have. Let's go back to 20 hertz again. And watch this, okay? Nice and stable. Nice display. Got a nice sync there, okay? Let's stretch it out even once more. Now let's put it right there. Now, watch this when I crank in more negative feedback. See, I've got this thing up set that says clockwise decreases feedback. So I'm going to turn it counterclockwise and increase feedback. Now when you get too much feedback in there, watch what's going to start happening. See that? That's what I was experiencing in some of my other amplifiers. It just gets really weird. Look at the plate current. Something's going to blow here. Just watching the plate current, I can start cranking the feedback in. See, it's still not right. It looks, you can see some of those anomalies popping in there once in a while. It's still not stable, and it's not stable because there is too much feedback. So, interestingly enough, I didn't think that this meter right here, watching the plate current, would be such a good indicator. Whoops, I'm cranking more feedback. Now at 20 hertz, we can actually see the needle vibrating, but to make it actually settle down, okay, there it is. Let's crank it back down there. Okay, now I'm going to go back. Well, let's go to 200 hertz. Okay, see if we can. Let's watch this meter again. And we're driving it up at 30 watts. Well, let's back that down a little bit. We're down to 23 watts. Gets tedious here working with one hand. I'm going to crank the feedback up. So our power starts dropping. I'm watching the oscilloscope and the meter at the same time. Yeah, see, it starts getting pretty weird there. But it seems like the real telltale place of trying to make stable is actually down here at really low frequencies. And I have to see more feedback, more feedback, more feedback, more feedback, More. There it goes. See, and that's going wacko. And you can see what it's starting to do there. Let's see what it does at that point at 200 hertz. Yeah, it starts that very slow oscillation up and down. See, about a half a cycle up and down. See, it's trying to oscillate with too much feedback. Now, I don't know how much that is, but boy, that is a real telltale right there, isn't it? That's from too much feedback. So I'm going to just increase the feedback until it stabilizes. I don't want any of that bouncing up and down. That looks pretty stable. And then go back to 20 hertz. And it's 17 watts. I got about 2%. 17.85 watts, 1.8% to 2%. That's at 10.9. There's our 22 watts. I know I'm getting pretty tedious here, but I'm really trying to evaluate this transformer. It looks pretty darn good. Okay, let's run some of the Pete Millett programs on it using the 8903 to scan it. Okay, our reference level is 20 watts. There it is, 20.7 watts. We're setting our reference at 1 kilohertz. Right now it's 0.6%. These numbers up here are from, this is actually voltage now, and that's the frequency, because when these two lights are on, it means it's under in remote. It's being controlled by the PC. Okay, let's go back over here to the PC. So we got it set up, and we say okay, and you can watch this thing. Turn on some lights. There we go. See, it says we're down about 1.5 dB at 20 hertz. Nice, rises up. Okay, and then we also see, we'll see the same thing here that we do on the decibel meter, that we get a slight increase. Oh, darn it. Sorry, you guys. I meant to put that out to 100,000 hertz. It runs pretty quick. Let's do this again. I meant to put in 100,000 hertz at 5 points per decade. It'll come back up in exactly the same spot. Yes, 100,000. Okay, there it is, down just a little over a decibel at 20 hertz FR of the transformer. Really windy here in El Paso today. I don't know, you might even be able to hear it. See, and then we start get that slight rise, like we did look at it on the Tektronix decibel meter. And then I don't know why it does that. I don't know if that's correct or not. Sometimes it is, and sometimes it's an anomaly. I'm going to say it's probably correct. So at 10, 20, 30, at 40 kilohertz, it does something pretty strange. Okay, let's run THD. Everything else should be the same. We'll put this at 5. I have to turn that on so I can see. 30,000. Start. Yes. Yeah, this is a voltage level right here, not a power level. I think this pretty well agrees with what we were looking at a while ago. About 1.3% at 20 hertz. Quickly drops down to about 0.75%. And there it is out there at the other end. Goes pretty high up there, huh? 3%. Now if we drop it down to, let's drop it down about 3 decibels, 7, 8, 9, 10, that'll be to half power. This will be at about the 10 watt level, and we're on trace 2. Let me get this. Now I know that's not a program anomaly, that goofy thing right there. Oh, I turned it the wrong way. One more time. Forget that one. That one was, I turned the 3 dB up. I doubled the power. I wanted to half the power. Yeah, that pink one. So we started at about 0.85. I'm beginning to think that a little bit of those goofy lines in there is because of the feedback. See, it's doing fairly nice at 10 watts. Whoops, okay. So at 20 kilohertz it went up to 2%. Let's do this. Let's tweak the, let's give it, which way should I go? Less or more? Let's give it that much less feedback. It's actually going to raise the power. But it smoothed it out. Let's do this again. Let's start another one. Power level, let's keep it down to, okay, there's our power. And our power, let's say that's 10, 9, 0, 8. Okay, there's 22 watts. Okay, I've got to work on it a little bit. Okay, now let's do another interesting thing. Let's start cranking in a shunt capacitance across the feedback resistor. This thing, I've got it set at 100 picofarads right now. And if we go up to 20 kilohertz, here's what we see. This is THD. Both of these are reading the same thing, about 1.9%. As I start cranking in more capacitance, it starts going down. 0.7, 6, 5, 4, 0.3, starts going way down to 2.1. This is up at 20 kilohertz. So that little bit of shunt capacitance up there makes a huge difference. Of course, it's also reducing the power down to 0.13. And then I think it starts rising here again in a minute. No. But let me show you what that shunt capacitance does down here. At 20 hertz, it starts doing some very strange things. Yeah, look at that. Look even right there. But we have to crank it. Looks like, from what I can experiment with here, about 600 picofarads. Let's see, 600 to be right there. Looks like about 600 picofarads does okay. Yeah, that's at 20 hertz. .200 hertz. .2 kilohertz. We're still at 20 watts. And 20 kilohertz. Well, it power dropped down. Oh yeah, the power dropped down more than 3 dB. Power dropped way down. And our THD went way down too. Must be a compromise there. Got to be a compromise. Okay, so that means we got to start cranking this thing back out and raising our power back up. Yeah, putting in too much does very strange things to the low end. I think what we'll do is crank this thing up to about 0.5%, so we're down at 14 watts. So you see that capacitor affects the high end. Well, let's run it up to about, let's see, we don't want it over 1%. What about 0.75%? There you go, 0.7. Let's see what that looks like. So you win one thing and you lose another, and that's at 300 picofarads, 350, 348, 350. Okay, pretty good, huh? So we're getting better. We do need that shunt capacitance. So now let's test it. Look at this. It's getting better. It's about 1.3 at 20 hertz. It's 0.8 at 20 kilohertz. Doing pretty good. And that's at 20 watts. I'm going to keep tinkering one way or the other, and so you're not sitting here watching all these things scan. And I'll show you the final result, and so you can see it scan and see it for real. It's getting better. Okay, I think I'm satisfied. That's 350 picofarads. That would be exactly right there. 350 picofarads, which a couple of picofarads doesn't matter, but 50 does, and here's what I'm satisfied with. This is at 20 watts, full 20, like 20 and a half. I got 0.9% THD at 20, got 0.8% at 20 kilohertz, and if we look down here at this thing, look at this one, let's see, I'm looking for a frequency response. Now let's see, this is THD. Okay, there's FR up there. No, darn, now I've lost it. Okay, well anyway, okay, well let's just do it again. It's quick and easy. There's my curve. It's symmetrical. What I've learned is by tuning the feedback capacitor, the little shunt capacitor, I can change this dramatically. Let me just show you what some of them look like here. THD. Well, these things are confusing me. Oh well, now it's figuring itself out. Oh, there's what I wanted, yeah. I'm sorry this thing's in the way, I can't move it. But see, here, I've tailored this. I don't know if you remember, but without a capacitor, this thing actually had a gain. So it went over like this and went up. So I adjusted that capacitor until I've got the exactly the same amount of attenuation at 20 kilohertz. See, there's 30, so there's 20, as I do at 20 hertz. And there's my THD, 0.9 to 0.8. But if you look at some of these other ones, if I can, hope this will make sense. Yeah, this is when I was cranking in more and more capacitance. See my THD dropping here? That's with like 550 picofarads. And then I'm going 50 picofarads at a time, then I go up here to 500. See, it raised about 0.1. Watch this one right out here. And then I go up here to this one. See, it went up another 0.1%. Another one. Another one, another one, another one, and then I think I get into some weird ones here. But this is when I was dialing in, and each time I put in 50 more picofarads of shunt capacitance, this one right here would go down one, just like that. But it starts getting some goofy lumps in here too. If this wasn't in a way, you could see it. It starts doing some strange things to the low frequencies, not the mid. But anyway, the two I'm going to settle on is that one as THD, and that one is frequency response. I think I'm pretty happy with it. So there it is. So actually this little capacitor box came in nice and handy too. So I'm not actually swapping them out. I can just dial it in. Love it. So I hope you guys get something out of this. I don't know what the value, I'll have to turn it off and turn it over and read this value right here. I'm going to take this out and put in a fixed capacitor with a 350 picofarad capacitor across it, a fixed resistor with a 350 picofarad capacitor across it. And there it is. So I'm running these things at pretty much their full plate dissipation while they're just sitting there. 40 milliamps on that tube, 44 milliamps on that one. They're nicely balanced. I don't know what the bias voltage itself is, but anyway, so what I have done to recap here is I have oh, sorry, thought I had that thing still up there, but I guess I didn't. But it's pretty easy to find. Acrosound transformer. So it's this this circuit right here, what I just showed you earlier, with the James output transformer. I'm using 350 picofarads, and I'll have to look and see what that is, and I'll make a note of it. And seems to be doing quite nicely. Let's see if we can do one more thing. It seems to be also stable down at 20 kilohertz. Let's see where the clipping point is now at with a steady tone of way overdriving it. Let's see. 1 kilohertz. 41 watts. Crank it down. Bring it down, boys. There we go. Okay, let's see. 4, 3, 2, 1, 0. 0. What's that? That's 10, 9, 8, Okay. Let's get it to where there's clipping right there. There's right below clipping. Right below clipping is, there it is, 40 watts. 40 watts. Right at a kilohertz. Set it right on, there it is. That's not that important. 0.5% THD. 0.5% THD. We can make this one read power to. We have to take it offline if you're not familiar with these. This takes it off the computer. Then you say clear 19.8 special. Then it reads the power again. So it's 40.3. That's what that one reads. This one reads 40.4. Not bad. I like these little guys. I'm going to use both of them and make something stereo out of it now that I'm pleased with it.